Hello. So in this video, I'm going to go over practice examples using the inverse trig function flowchart that I designed. So I'm just going to kind of give you an assortment of different problems, and the idea is how do I use this flowchart. Now there is another video that describes the flowchart and what it means, and has some examples. But this is intended to kind of test you. So this is the flowchart, and I'm not sure if it's too small, but if you're in my class, you can download it. If you're not, I'm going to see if I can zoom in on it as we're doing some of the problems. All right, so here are the problems I'm going to go over. If it were me, I would go ahead and write those down, pause, after having watched the first video on how to use the inverse trig flowchart, then I would try to do these and then watch the rest of this video to see if I'm doing it right. At least if I couldn't get through it, I would know what questions I'm having, right? All right, and let me see. I think we can use more light. Yeah. Although, I think there's a shadow from what's holding up the glass plate for my phone. Anyway, let's start on number one. Now in number one, find cosine of cosine inverse of 2/3. So when I'm using this flowchart, remember what I want to do is I want to look and say, okay, is it one function or two? Well, there's two. And then, so I'm here on this side. So this is the one function, two function. Now that I'm in the two function area, I want to ask, are they the same or different? Well, they're the same. So, because there's cosine and cosine inverse, cos. So now I want to say, well, they're the same. Now I want to look at the order of the functions. Is the inverse function on the inside or is it on the outside? Well, it's on the inside. So if it's on the inside, I follow this. So I have to check to see if the input is valid. If it's not, then it's no solution. If it is, then I just use the identity and the answer is x. So when I look at, is 2/3 a valid input for inverse cosine? Well, inverse cosine, remember, the range of the trig functions becomes the domain of the inverse trig functions. So what numbers are allowed in? For cosine, anything between -1 and 1, 2/3 follows in there. So therefore I can use the identity that basically says, hey, f inverse, they cancel each other out, and I just get x. So the answer is 2/3. Right? So this is the idea. I take a bus from Orlando to Jacksonville, and then I take another bus from Jacksonville back to Orlando. So where am I? I'm right back where I started. So that's the idea. I started here. That's where I'm right back where I started. Okay? Let's take a look at number two. Okay. So on this one, when I use my flowchart, I say, well, is it one function or two? Well, it's two. I got cotangent and sine. So I'm in the two function area. And then I'm saying, are they the same or are they different? Well, they're different. One's cotangent, one's sine. It's not like I have sine inverse or cotangent inverse cotangent. Right? So then I follow this set recipe. I let the inverse trig function be theta. I rewrite the question so I know what I'm finding. I take the trig function of both sides, not multiply. I take the trig function. I set up a right triangle and then, use the Pythagorean Theorem to find all the sides. And then I finally answer what I'm really being asked, which is part B. All right, so let's go through that. A. So this here is essentially an angle, theta. Because remember, for a regular trig function, in comes an angle, out comes a ratio or a number. So it gets switched for an inverse trig function. In comes a number, out comes an angle. So the answer to this is an angle. So I'm going to say let theta be inverse sine of -4/5. Okay. Now, part B, I now rewrite the question with the substitution that I just made, because that's really going to tell me what I'm trying to find, what I'm being asked. So this is really cotangent of theta. So they're asking me to find cotangent of theta. All right. So now part C, I work with my definition that I let theta be the inverse trig function, and I take the trig function of both sides of that. So I let theta equal inverse sine of -4/5. So now I'm going to take the sine of both sides, and I'm saying it that way. I know you heard it in my voice, right? Because a lot of students will think, oh, I'm going to multiply both sides by sine. Well, sine's a function. You're really not doing that. What you're doing is you're taking the sine of both sides, which means you're extracting the information, which is the ratio y/r for that particular angle. Okay. All right, so these two undo each other, and I get sine theta equals -4/5. Okay. Now, what happens is I know the definition sine is y/r is -4/5. So r is always positive, so r is 5, y is the -4. And then when I go to represent this, if you recall, the inverse functions, and you can, well, yeah, that's right. You can use this, or they're really in two different places. For sine, it's quadrants, what, 4 and 1. So what I want to do, because I have a negative sign, I want to actually represent this in this quadrant here. Here's theta. What you get is y equals -4 and r equals 5. Now I use the Pythagorean Theorem to find x. So I say x squared plus y squared equals r squared. So x squared plus a -4 squared equals 5 squared. X squared plus 16 equals 25. So x squared equals 25 minus 16, or 9. Take the square root, right? So I get the absolute value of x is 3. So x is technically plus or minus 3. However, I know I'm in quadrant 4, so x is positive, so I have x is 3. Okay? So now that I have all these three, I have all the information I need, right triangle. Now I'm going to come back here and actually answer the question for part B. So, what was part B? Find cotangent of theta. That, so I can actually fit this on one page. Or I'll go to the next page. But I want to find cotangent of theta. So these pens really bleed. So when I find cotangent of theta using this, what's the definition of cotangent? And you should know that without looking it up. So x over y. So now I look at my triangle and I say, oh, x is 3, y is -4. So you could write it -3/4. And it doesn't really matter if you write it like this or like this. They're all the same. But that's your basic answer. -3/4. Okay. All right. Next one. So again, you really want to try to do this before I go over it. So like pause and do it, or maybe you've done it all at once. So on this, I say, is it one function or two? Well, it's one function. It's just a regular inverse trig function. So what do? I check to see if the input's valid. If it's not, it's no solution. If it is, I make sure I ask the question, for what angle in one of these intervals is the ratio equal to the given number? And of course, the interval has to correspond to the function. So for tan inverse, I say, so first of all, for tan inverse, everything is good, right? For tangent, all reals are inputs. So now I'm like looking in here. So I say, for what angle, somewhere between -pi/2 and pi/2, not including the endpoints, is the ratio y over x equal to square root 3? Right? So here it is. For what angle in, and I like to draw the picture because it really just reinforces things, right? So in -pi/2 to pi/2, but not included, right? Is the ratio, because it's tangent, it's y over x, equal to square root 3, right? Now, technically, you can always, the ratio has two numbers, so you could always put this number over 1, right? You can always put a number over 1, it doesn't change anything. So I'm looking for where y is square root 3 and x is -1, or really, you want to think about your unit circle. I really could multiply both of these by a half, right? So I'd have square root 3 over 2 and a half, but what I want to do is, I know I want to use probably either it's just here, since y is positive, I'm in quadrant 1, pi over 6, right, where you're going square root 3 over 2 and then up a half, or pi over 3 where you're going over a half and up square root 3 over 2. Now you could try either one, right? You could try both of them and say, oh, well, let me find the tangent of pi over 6, let me find the tangent of pi over 3, and then whichever one ends up being square root 3, that's the answer. But let me help you out. The y is the one that's got the square root 3. So here's x, here's y. It's going to be pi over 3. So if I just check tangent pi over 3, definition is y over x, coordinates are square root 3 over 2 over a half, flip and multiply. Right, so these cancel out, and I get square root 3, that's the one. So the answer is pi over 3. All right. Okay, next one. Find the inverse sine of negative 7/5. So I look here and I say, okay, one function or two, it's one function, just an inverse sine. I check to see is the input valid. Well, for sine, only numbers between negative 1 and 1, including the endpoints, are valid. Now, is negative 7/5 inside? So if you look at it here from negative 1 to 1, right, is that number negative 7/5 in here? Well, remember, negative 7/5 is actually negative 1 and 2/5, right? So that's actually somewhere here. So it's not in here, therefore not a valid input, no solution. All right. All right. Next one. Find the inverse sine of negative 1 over square root 2. So that's just one function, right? You ask 1 or 2, one function. Then you got to check if it's valid or not. It is. If you took this number and put it in your calculator, it would be less. It wouldn't be less than negative 1, right? Because it has to be a number between negative 1 and 1. So now I ask for what angle between negative pi over 2 and pi over 2 is y, because it's sine, equal to negative 1 over square root 2. So for what angle in negative pi over 2 to pi over 2, right? And here's your picture. Is the angle, oops, not the theta, sorry, is the ratio, and sine, the ratio underlining sine is y over r, but we're going to let the radius be 1, so just y equal to negative 1 over square root 2. Now, if you're not sure, you're like, looks kind of familiar. You remember in your unit circle, you do have square root 2, and that's usually with some multiple of pi over 4. Some people memorize the unit circle this way, or if you take your number and you rationalize it, it'll become more obvious. This is the way most people memorize it, negative square root 2 over 2. So you're like, oh, okay, it is definitely here. And since I'm only allowed to be here, it's going to be right here, where I'm at square root 2 over 2 for my x-coordinate, negative square root 2 over 2 for my y-coordinate. And normally you know that as 7 pi over 4, but remember your answer could only be in here. And if you're not careful, here's what happens. Here's like negative pi over 2, here's pi over 2, and somewhere way out here is 7 pi over 4, right? And you have to be in here. So you've got to rename this and say, oh, but okay, a coterminal angle for 7 pi over 4 would be if I go around the circle once in the negative direction. So if I subtract 2 pi, that would be minus 8 pi over 4, right? There we are. That's another name for the same location. So I just rotated had a different rotation to get there, but it's the same location. So therefore the coordinates are the same, therefore the y coordinate I'm looking for will work. But now I've got the angle named in the correct interval. Okay, so your answer is negative pi over 4. And then let's see here. Number 6. All right, so here you would ask one function or two. It's two functions. Are they the same? Yeah, tan inverse, tan inverse tan. What's the order? Well, it looks to me like the inverse is on the outside, so I'm following this. So the first thing I got to do is check to see if the angle is in the correct interval, and this is a tangent, so it'd have to be between negative pi over 2 or pi over 2, not including the endpoints. So 5 pi over 6, where's that? Well, 5 pi over 6 is over here, and I'm supposed to be somewhere in here. So I'm not in the interval, right? I'm not in the interval. So I can't just use, so what that means is because I'm not in the interval, right here. So no, then I have to evaluate the trig function. Because if I had been in the interval, I could just use the identity and the answer would be x. But I have to evaluate the trig function first and then plug it into the inverse and get that. So let's do that. So what is the tangent of 5 pi over 6? So this is the evaluation part. Well, at 5 pi over 6, I go what? Over negative square root 3 over 2 and up a half. So the ratio y over x is 1/2 over negative square root 3 over 2, which is 1/2 times negative 2 over square root 3, right? 2's cancel out. And basically I get negative 1 over square root 3. Okay, and if you rationalize it, you multiply by square root 3 over square root 3. It's up to you. But this is the answer to this part. So that means now I have to find what is the tangent of the negative 1 over square root 3. Because I just found all this to be negative 1 over square root 3, so I'm going to plug that in there. So now I went from a two function question down to one, and it's just a regular inverse question. So now we're here, and I got to check if it's valid. It is valid because we just did it. Got a number. And now I have to say, well, okay, for what angle in the interval, somewhere between negative pi over 2 and pi over 2, is the ratio y over x equal to negative 1 over square root 3? So let me write all that on another piece of paper. So 4, so this is still 6. What angle somewhere in negative pi over 2 to pi over 2 is the ratio y over x equal to 1 over square root 3? Oh, it's negative, by the way. All right. So you're like, okay. Well, first of all, what quadrant am I in? Since this is negative, and I can only work with quadrants 1 or 4, I must be in quadrant 4, right? I'm somewhere in here. And remember, you know you've got a square root 3, so it's got to be a multiple of pi over 3 or pi over 6. But we can do a little better than that, right? It's the x that is the square root 3 coordinate, right? So, oops, sorry. So what I'm looking for is x goes over square root 3 over 2 and y goes down what? Negative 1/2. So I'm looking for here, somewhere here where x is square root 3 over 2. And then y must be negative 1/2 because y is negative in the fourth quadrant. So what is that? Well, that is 11 pi over 6. If you know you got to know your unit circle really, really, really well. But you can't call it 11 pi over 6 because why? That angle, your answer has to be between negative pi over 2 and pi over 2. We're back into that situation where here's negative pi over 2, here's pi over 2, right? And it's like this, it's somewhere in here. And then way out here is 11 pi over 6. So I have to rename 11 pi over 6 so that it fits in here. I have to find the coterminal angle for 11 pi over 6 that's somewhere between negative pi over 2 and pi over 2. So I'm going to subtract 2 pi, which would give me 11 pi over 6 minus 12 pi over 6, which will end up giving me negative pi over 6. So my answer is negative pi over 6. Okay. Okay, let's see, which one did we do? We just did, yes. Okay, 6, so let me keep going. Number 7. All right. So here again, use your flow chart. Is it one function or two? It's two functions. Are they the same? Yep. So I'm here, right? Not here, where they're different. They're the same. And the inverse is on the outside. So I'm following this. So I'm going to be able to find an answer. The idea is, can I use the identity or not? It depends on whether the angle is in the specified interval. So negative pi over 3 for cosecant. So cosecant is here. Negative pi over 3 would be here in quadrant 4, and it is between negative pi over 2 and pi over 2. So you're like, yes! Therefore, I can use this identity. So I know that f inverse f of x equals x. So this is negative pi over 3, right? Bing, done. I love that. Number 8. So 8 is going to be similar to 7 with slightly different numbers. Actually, no, but they are switched. Sorry about that. So these are two functions, same functions, but in this case, the inverse is on the inside, right? So the first thing I have to do is check to see if it's valid. Is a half valid as an input for cosecant? Now remember, cosecant can't take any fractions, no fractions. That's a fraction, so guess what? No solution, it's not a valid input. So, can't do it. All right, that's 8. Number 9. Okay. Again, you're working with two functions, same functions, cos, cos. And in this case, the inverse is on the outside. So you will come up with an answer, you just don't know if you're going to be able to use the identity, or you have to evaluate the trig function first. So, is pi over 2 in this interval? So cosine is specified for pi 0 to pi, and pi over 2 is right in there. So that actually works. Therefore, you can use the identity f inverse f of x equals x. So you just have the answer pi over 2. Done. And finally, number 10. So you're looking at two functions. Are they the same or different? They're different. So I've got to follow this procedure, right? So I'm going to let the inverse trig function be inverse cosine of negative 3/8. I'm going to rewrite the question. So it's going to be, I'm trying to find cosecant of theta. Then I'm going to take the trig function of both sides and create a right triangle and then answer part B. So let's do that. So I'm going to say, A, let theta equal inverse cosine of negative 3/8. So what I'm trying to find is actually find cosecant of theta. That's what I'm trying to find. So once I have the triangle and all of the sides, I can answer that, right? I'll just pull out the information, r over y. Now, because I let theta equal inverse cosine of negative 3/8, I take the cosine of both sides, right? I'm not multiplying. I'm taking the cosine of both sides, which does what? It extracts the information, x over r, from that angle. These two undo each other, and I get cosine of theta equals negative 3/8. All right, now, because I want to draw a right triangle, I remember that cosine is valid from either quadrant 1 or 2, so I want to put this in quadrant 2, right? So for D, when I say, oh, okay, here's my triangle that we're representing, here's theta, and I know that x over r equals negative 3/8, and obviously the r is positive, so r equals 8, x equals negative 3, and what does y equal? Well, we're going to have to use the Pythagorean Theorem, and then come back and answer that. So, we have x squared plus y squared equals r squared. So negative 3 squared, plus y squared equals 8 squared, right? Okay. And so now I'm going to say 9 plus y squared equals 64, right? And so now I'm going to subtract 9 from both sides. I'll get y squared equals 55. Take the square root of both sides, get the absolute value of y equals square root of 55. And by the way, if you do a factoring tree on that, it's 5 times 11. My cat might help us here. Miss Bobo. Oh, Bobo, you just, yes, I love you too. But you do have to move. I know, everybody wants to see you. Go ahead. All right, so, no, you really do. All right, I'm gonna have to put you down, aren't I? Okay, if you just stay there, it's fine. So here, y is equal to, I remove the absolute value, so y is equal to plus or minus square root 55. And remember, because both of these numbers are prime, you can't pull anything out of the square root. Oh, no, you don't. You know, he's being a typical cat. So now I have to decide, is y positive or negative? Well, I go back to my quadrant. I'm in quadrant 2, y is positive. So y is positive square root 55. So now I can write that down here. Y is positive square root 55. And now I go back and answer this right here, right? I'm trying to find, for E, I'm trying to find cosecant of theta. Just make sure y'all can read all this. Yeah. And that is r over y, which in our case is 8 over square root 55. And, you know, most books will, I think almost all books want you to rationalize it. So you'll have 8 square root 55 over 55, and that is your answer. Now, just in case you need to see any of this work, there we go. All right, so that's it. Those are the 10 problems. What I want to say as a parting comment is this is, I think, the most difficult topic in trigonometry. It requires all your knowledge of trig, and then you have to keep this framework in your mind, right? This whole flowchart. So don't be hard on yourself. It's going to take you do need to get this in, and what you need to do is practice. And if you did these 10 problems without following me, but you tried them on your own first, my guess, based on what I've had with students, my work with students and face-to-face, they think they have it, but they don't, right? It makes sense when I do it. That's all great, but then when they have to do it, it's still, ooh. So you just really need to practice. That's it. But this is certainly doable, and now you have an organizational framework for it right here. Just practice and you'll get it. But remember, the way you'll know you really have it is when you have this flowchart, almost like an invisible teleprompt, where you can see it, right? And so you know what to do. You know what to do when. Thanks so much for listening.